In this lesson, we are going to be learning some different facts about triangles. Our first fact is in regard to the interior angle sum. This basically says that all of the angles in a triangle have a sum of 180 degrees. We're also going to be talking about different ways to classify triangles. This is different ways to name them. So we can classify triangles by their sides, and the options we will choose from are scalene, that's a triangle that has no equal sides, isosceles, that's a triangle with two equal sides, and equilateral, where all of the sides are equal. When we classify a triangle by its angles, our options are going to be acute. That means all of the angles, all three of them, are acute angles. It could be a right triangle where you have one 90-degree angle, or it could be an obtuse triangle where you have one obtuse angle that's greater than 90 degrees. We'll take a look at the angle-side relationship. This basically says that in a triangle, the largest side is always opposite or across from the largest angle. If you think about a right triangle, we know the hypotenuse is the biggest side, and the 90-degree angle is the biggest angle, and they're across from each other. Similarly, the smallest side of a triangle is opposite the smallest angle. And finally, the fourth fact we're going to work with today is the triangle inequality theorem. This basically says that in order for a triangle to exist, the sum of the smaller two sides must be greater than the third side. So we cannot always take three side lengths and put them together to form a triangle. So for instance, if I draw an example here, I could draw a triangle and say it has sides 3, 4, and 5. 3 and 4, when I add them up, it's greater than the third side, so that works. However, if I think of another example, let's say I try and draw a triangle that has sides 2, 2, and 4. Those sides of 2 are not going to be able to actually connect and form that third angle. And that's because it fails to pass the triangle inequality theorem rule. So the sum of the smaller two sides is 4. That's not greater than 4. So those three sides would not be able to form a triangle. So let's take a look at some sample questions that go through those 4 ideas, and we'll practice them thoroughly. Starting with number 1, a triangle has angles of 56 and 63. And we want to know what is the measure of the third angle. So we know that 56 and 63 gives us a sum of 119. Since the angles in a triangle add up to 180, let's subtract that from 180 to find the missing angle. And our third angle is 61 degrees. Number 2, what is the measure of each angle in an equilateral triangle? So an equilateral triangle is one where you have 3 equal sides, but you also have 3 equal angles. So if the sum of the angles in a triangle are 180 degrees, when I divide by 3, I get 60 degrees. So all 3 angles are going to be 60. That means that it is equilateral, and it gives us that interior angle sum of 180. Number 3, in triangle ABC, AB is 5, BC is 6, and CA is 7. Which angle of the triangle is the smallest? I would personally suggest drawing a picture out for this, and it's okay if your picture is not necessarily drawn accurately. We just want to be able to visualize what the smallest side is and the smallest angle in order to see which ones are opposite one another. So I can definitely see that the smallest side is going to be side AB, which is 5. So drawing the picture helps us realize that the opposite angle, the one across from it, is angle C, and therefore angle C is the smallest angle. So again, remember the smallest side and the smallest angle are across from one another. Number 4, we actually looked at these numbers already today. Can a triangle with side lengths 2, 2, and 4 exist? And explain. This is no, because the sum of the smaller two sides is not greater than the third side. right, let's continue on and look at some more examples. Number 5, a triangle has angles of 42 and 78. What is the measure of the third angle? So if I add those up, 42 and 78 gives me 120 degrees. When I subtract that from 180, I get 60 degrees. Then it asks us, how can I classify this triangle by its side and angles? So that's where if I scroll back for a second, I want to pick an option from each of these columns. I want to decide, is it scalene, isosceles, or equilateral? And then for angles, is it acute, right, or obtuse? It might be easiest to start with the angles. I see that all 3 angle measurements are less than 90, therefore they're acute. So this must be an acute triangle. Since they are all different values, 42, 78, and 60, none of them are equal to one another. Since none of the angles are equal, none of the sides will be equal, and therefore this triangle is scalene. Number 6 is very similar. So we have now angles of 17 and 146. When I solve for the missing angle here, I get 17 degrees. If I classify this triangle by its sides and angles, I see that obtuse angle in there, that 146. So this is definitely an obtuse triangle. And since there are 2 equal angles, right, there's 2 angles that have a measure of 17 degrees. That tells me 2 equal angles, gives me 2 equal sides, and therefore this is an isosceles triangle. Number 7, solve for x. Well, I see that I'm given the 3 angles in a triangle, and I know that they add up to 180. So I'm going to create an equation, 4x minus 1 plus 3x plus 90 equals 180, and then I'm going to start by combining like terms. And now we're going to work to isolate the variable. So subtracting 89 to the other side, I get 7x is 91. Divide by 7, and x comes out to be 13. If we wanted to check it, we could certainly plug back in. Make sure if I plug in 13 here, I'm going to get 39 degrees. If I plug in 13 here, I'm going to get 52 degrees. 51 degrees once I subtract 1. And I see that my angles in the triangle do add up to 180. Number 8, in triangle JKL, angle J is 40 and angle K is 40. Which side of the triangle is the largest, JK, KL, or JL? So again, this reminds me of one of the problems from the first page where I think it would be a lot easier to answer this problem if I had a picture. And when we draw the pictures, it's okay if our pictures are not drawn accurately. We're just kind of getting an idea of what this triangle looks like and what sides and angles are opposite one another. So J is 40, K is 40. And I can go ahead and figure out the measure of angle L since I know the triangle has to have 180 degrees. That makes angle L 100. Now we can examine and figure out which side is the largest. So the largest angle is going to be that 100, right? Angle L. So to find the largest side, I want to figure out what side is across from it. That's going to be JK. And that's our answer for number 8. Number 9, the angles in a triangle are in the ratio 5, 6, 7. What are the measures of the 3 angles? Whenever you're given measurements in this ratio, I would always suggest thinking about what kind of equation you're going to be able to write. So in this case, I know the angles add up to 180. And then we know 5, 6, and 7 don't add up to 180, but some multiple of those values does. So we're going to put x's in here. So 5x plus 7x plus 6x, equals 180 degrees. Combine like terms. And when I solve, I get x equals 10. So if I want to find the measures of the 3 angles, well, 5x, 5 times 10 is 50 degrees. 6x, 6 times 10 is 60 degrees. And 7 times 10 for the 7x gives me 70 degrees. And sure enough, 50, 60, and 70 does give me an interior angle sum of 180. All right, a few more questions on this. We see a very similar problem right after this, but now they're in the ratio 1, 1, and 2. So I'm going to go ahead and add x's in there to create my equation. And I'm going to repeat basically the same algebra process, combine like terms, isolate the variable. And so that 1x, or that 1 times 45, of course, just gives us back 45. And we have two congruent angles there. And the 2x gives us 2 times 45, which is 90 degrees. So our three angles are 45 degrees, and 90 degrees. Number 11, can a triangle exist with side lengths 5, 8, and 12? Well, let's check. Is the sum of the smaller two sides greater than the third side? And yes, the sum of the smaller two sides, 5 and 8, gives me 13. That's larger than 12. So I'm going to start by definitely saying yes. And I'm going to say because the sum of the smaller two sides is greater than the third side. All right, for our last question, if two sides of a triangle have lengths 9 and 14, name one possible side length for the third side. So since it says one possible side length, there are multiple correct answers that we could have for this question. So in order for the triangle to exist, remember the sum of the smaller two sides must be greater than the third side. So I'm just going to start with coming up with an example. Let's say I do a little trial and error, and I think that the third side is going to be, let's say, 3. If I look at those three numbers, is the sum of the smaller two sides greater than the third side? No. So keep in mind the smaller two sides are not always the two sides that are listed first. We have to pick the two that have the smallest value. So 9 and 3 is not greater than 14. So I know, okay, 3 does not work. Let's say I try another example. Let's say I try 7. Is 9 plus 7 greater than 14? Yes, that does work. So 7 is a possible answer. When we're going through this, if you're trying other examples, all of the numbers that are between 5 and 23 are going to be acceptable answers here. A quick way to kind of get this compound inequality of how to figure out these values, the 5 is what you get when you subtract the two given side lengths, so 9 and 14. The 23 is what you get when you add the two side lengths. So any number that's between 5 and 23, and it could be a decimal too, would be a possible side length for this third side. Hopefully this lesson helps you understand a few basic rules about triangles.